Yeah, hi guy. Welcome to my channel. Now, today exercise, we're going to take a look at star delta programming. This is my logic program, and this is my schematic, the power circuit schematic. All right, I use this one to illustrate the operational sequence of this logic. This is my program. I'm going to download this program into my PLC Siemens logo. This particular one is Siemens logo. Then we're going to illustrate how this contactors closes and opens their operational sequence. Then how the motor will also show arrow, showing the direction of rotation. All right. Then the termination sequence is this. These are my input devices. Then this other side is my output devices, where you terminate your output devices, and this other side you terminate your input devices. Then for the program, these are my output bits. Then this other side, they are all input bit, right? Okay, let me change the dimension of this so that I can visualize the CPU. Okay, take a look. The P1, P2, they are my input where I energize my um, Siemens logo. Then I1, I2, I3, I4 to I8. These are where you can input your input bit. Then this other side is your output bit. I have only 4 output bits here, only 4. That is why this star delta programming, I don't have indicator lamp for star operation and for delta and the changing over of mains. So the only what I have here is one indicator, that is this particular one. So when the operation is on mains, when you energize the system, this one and this one will come up immediately, simultaneously. Then by that time, I don't have indicator lamp because what I have here is output device of 4 output only. So and that 4 output is 1, 2, 3, 4, right? So what I did, I now use only one output of indicator. That is for only for star. When the system now changes to star operation, that is when this indicator will come up, being this particular one, right? Okay, then this one is for my fourth lamp. This one is my fourth lamp. When the overload trip, this one will come up. It's alarm. Then you also remember that we have a HMI, human machine interface. So this is my mini HMI. I just represent start and stop button here as my HMI. I can also start here. Now, the advantage of this particular logo PLC is because you can, this particular software in question, you can terminate your programming. After writing the program, you can also input the connections to the terminals. Most people know how to write a program, but they don't know how to identify their termination process from the PLC. So that is the advantage of this particular exercise. Having known the programming process and the operation sequence, you will now also understand the termination process on how the start buttons, start and stop push buttons, and the overload, how you can terminate them from your CPU PLC. Then the output devices being this one and this other one, you will now know how to also terminate them to your output bit of the PLC. Okay. Then if that is taken, let's see if we can simulate and now understand the operation sequence. Once I energize the system by pressing this button, this one, this particular button can be in your control room. Meanwhile, this other button and this other enclosure, this power circuit schematic, will be enclosed right inside the panel, and the panel may be situated somewhere considerable distance from the control room. That is why I introduced this one. This one can be in your control room. Meanwhile, the entire panel can be situated in the field close to where the motor will be installed. So that's the advantage of having an interface starting position being this one. So from this programming, it can start from here and stop from here. It can also start from here and stop from here, right? This is just for a beginner process, basic PLC programming and wiring for beginners. So as a beginner, you pay very good attention to the process of this operation and this exercise, right? Okay, let's simulate. But before then, I'll walk you through the operation sequence. Once I energize the system by putting on this button or pressing this, This contactor K1 and K2 will close simultaneously. This is main contactor or line contactor. This is star contactor. Both of them close the same time. Then after a few minutes, 3 or 4 minutes, this one will take over and this one will get de-energized. So in that case, the motor will be fully subjected to full load, right? That is the high speed. Okay. All right. Now, this particular timer, I put it on 70 seconds so that before then, I will also walk you through on how all of them will indicate their operational signals. So let's do that now. Okay, let's simulate. Put on the breaker. Now, the screen will now come up. Either you start from here or you start from here. But let's start from here. I start the operation. This one close and this one close. The motor gives you arrow of direction that is going clockwise now. Now, when this one closes, this is the main contactor. When this one closes, it will latch with this auxiliary bit. Then this same auxiliary bit of this is this 1, 2, 3, 4. So 1, 2, 3, 4 bit. This 4 bit is an integral part of this main contactor. Once this one closes, the auxiliary contact of this, auxiliary bit of this, will take care of this and close the whole of this branch circuit, so that this power to the timer here can be energized. The power to this other star contactor will also be energized. The power to this delta contactor will also go through and stop here, pending when this one, the counting time will elapse. It will now change over. All right, the indicator lamp, I intentionally leave this place open. I don't want it to light up now until the system changes to delta. That is why I increased this to 70 so that I will show you, I'll walk you through how the indicators will be. Then later we'll change it to 3 seconds. Now these two contactors is showing that these two are in close mode. 1, 2, they are closed. So these two are closed as well. So this is how you can understand the operation of star delta. Right? Now let me change this to 3 seconds. Let me quickly change it to 3 seconds now. Make it 3 seconds. Right. Oh, can as well make it 4 seconds. So I will show you the shutdown duration. Shutdown a fault when in terms of fault. Okay, I put it on. I energize the system. These two closed simultaneously. Time start counting. When the time elapses, this one will take over. Got the load. This one is running now, and this one is up now, running. Peradventure there is a fault, overload will trip. This one will trip. When it trip, fault lamp will come up. Oh, there's a bug here. There's a bug here. All right. This one is not true. We are supposed to terminate this. There's a bug here. Let's do that now quickly. All right. We're going to link up this to this. Okay. So let's test once more. Put on the system. Energize the system. It's now running. After preset time, this one take over. All right. Delta take over. Run lamp come up. So let's create a fault by tripping the overload. Yeah. Alarm come up. This is the alarm. And for you to reset the alarm, if you don't want to go to the field to access the panel and reset from overload, from your HMI system, you can reset. Look at the reset lamp. I put it here. You can reset from here. After you reset the system, you can now go and there start again. Like I said before, you can start from here. You can also start from here and stop from here. All right. Thank you. So the next exercise, we're going to take a look at how you'll be able to write this program, the process of writing the program, right? All right. Thank you.